Cops will soon upgrade to license plate readers that can track your iPhone and AirPods in public, but they can actually track anything that has a Bluetooth signal, including people who have been implanted with the bio-cyber interface, and I'm about to prove it to you. Signal trace sensors collect data from Bluetooth and Wi-Fi as well as Rfid tags. It categorizes the signals by device and links it to the data shot by automatic license plate reader cameras. The idea is that, as well as grabbing all of this data, it can be used to create a digital fingerprint of a person or a group of people. It stores that data for the authorities, but also uses it to track trends such as when two phones are consistently spotted traveling together. And it don't matter if you got your phone or not, because they're tracking your Bluetooth signal. This can lead to the discovery of convoys and other movement of travel patterns. An integrated signal intelligence system identifies suspects by the electronic devices they use or have implanted in them. Signal Trace is a groundbreaking software system for law enforcement designed to identify suspect people or vehicles even when a license plate number is not known. This system integrates seamlessly with the ELSAG Enterprise Operations Center, our standard data management and analysis software. This system uses strategically placed sensors to collect electronic communication patterns and identifies of consumer electronics like vehicle components, Bluetooth, RFID tags, and Wi-Fi as electronic devices emit signals. Sensors in the signal trace software capture their identifying or categorizing details to create additional data set to enhance the records captured by LPR cameras in the area. That means they're tracking you everywhere you're going, even when the license plate reader can't see you. The IEEE set the standards for the bio-cyber interface because they're deploying it in everyone. They're either injecting it in people or they're spraying it on them, and the metamaterials assemble into biosensors, and lipid nanoparticles hybridize your cells and turn into Internet of Bio-Nano things, where every cell is basically infected and becomes a bio-nano machine. Nano network is comprised of several nanoscale devices such as nano transmitter, nano receiver, nano router, and other specialized nano devices to perform exclusive tasks like sensing, actuation, monitoring, and control. Intrabody nano network is generally deployed in the environment, human body orally or through injection. That means they're spraying it into the environment and you're orally taking it, breathing it in, or they're injecting you with it in a shot. So it's in everything. It's ubiquitous. To realize in vivo biomedical applications, the nano network consists of devices, nano machine, nano router, nano micro interface at nanoscale 1 to 100 nanometers, which work collaboratively to achieve sensing and actuation tasks. Nanomachines can be interconnected to execute collaborative tasks in a distributed manner. The size of nano devices make them feasible for in vivo applications where these non-invasive machines can easily be placed in hard-to-access areas deep inside tissue and perform therapeutic operations. Bio-cyber interface. Nano-micro interface is mediating device between nano and micro scale communication. It is referred to as bio-cyber interface and bioelectronics device throughout this article to keep the generality. Basically, this device converts electrical signals received as commands from the medical server of healthcare providers into biochemical signals understandable by intrabody nanonetworks and vice versa. Gateway devices are now an integral part of most Internet of Things applications, where they function as a relay device between sensors and the Internet. Gateway devices are computing devices such as smartphones, tablets, laptops, or mini computers. A gateway device supports the mobility of patients and ensures efficient signal reception of low transmission range technologies, NFC, RFID, Bluetooth Low Energy. The wearable bioelectronic devices are usually designed to be compatible with the operating system requirements of smartphones. For RFID-enabled applications, smartphones integrate with the RFID readout unit, which eliminates the need for external RFID tag readers. Similarly, for bioelectronic devices enabled with Bluetooth Low Energy as the communication modality, smartphones are the ideal choice. Access point can be a cellular base station or Wi-Fi access point, which helps to route the body's sensors traffic to the medical server. Medical server acts as a repository in which all the sensory data collected and sent from the patient's body is stored, analyzed, and processed. This server may act as a terminal for real-time and continuous health monitoring, where emergency situations can be mitigated by sending alert messages. Only authorized entities can access this server to send commands and receive collected data due to critical nature of biomedical applications. Biocyber interface is the hybrid and most sophisticated device that is capable of communicating between nanoscale and microscale devices. Biocyber interface can be made from graphene or carbon nanomaterials that build a graphene-based sensor for biological detection of Mach signals, graphene-based transistors for information processing, and graphene-based plasmonic nano antennas inside of people, and that's definitely been seen by microscopers. So that's what's happening from all the graphene that they're spraying on us, is it's growing a biosensor, biocyber interface inside of people without them even knowing it. And this is the other one down here, is electronic tattoo that goes on top of your skin, but no one's going to need that because they already got this other stuff inside of them. But people are still going to go get that